Okay, let's take a look at the 7.3 homework. So this one was numbers 3 to 23 odd on page 381. So we are going to start here. Okay. Sorry, my daughter is yelling in the background. Alrighty. So, okay. In exercise 3 to 8, state which theorems you can use to show that the quadrilateral is a parallelogram. So number 3, it's showing me that this angle and this angle are congruent with those little markings. And then it's showing me that this angle and this angle are congruent with the fact that they're both 100 degrees. So, whoa, I wanted to make it a little bigger. So that is how we end up with, sorry, just making a little adjustments. So that's how we can be sure that this is a parallelogram, because opposite angles are congruent, okay? And so whenever we work backwards to say something's a parallelogram, that's the converses. So in this particular one, it's going to be the opposite angles converse. Number 5. In number 5, it's showing me that this diagonal is bisected because this half and this half are congruent, and that this diagonal is bisected because this half and this half are congruent. So the diagonals have bisected one another. And again, because we're showing something's a parallelogram, that's the converse. So this is the diagonals converse? Uh-oh. Sorry, I think I want to double check that for you guys. One quick sec. Because I don't remember. I feel like there should be more words in that. No, it's just diagonals converse. Okay. Okay. This one is the only one that's a little bit different. So looking back at the notes on this guy, this is not a converse because this was a theorem on its own. It was the opposite sides parallel and congruent theorem. So this was like brand new. This isn't like the converse of a theorem that we saw previously. So here we have one pair of opposite sides that are both parallel and congruent. The same set of opposite sides are both parallel and congruent. So that makes it a parallelogram, and that is the congruent and parallel sides theorem. Okay? Opposite sides parallel and congruent. Opposite sides parallel and congruent theorem. Okay. Number 9. Find the values of x and y that make this quadrilateral a parallelogram. So we did this last time. What we've got is that we can use the opposite angles, congruent converse, to achieve this. So x will have to equal 114 and y will have to equal 66. In number 11, again, opposite sides must be congruent. So we must have 4x plus 6 be equal to 7x minus 3. So I'm going to start moving things around, minus 4x on both sides. And then I'll add the 3 to both sides. And what I get is the 4x's cancel. 6 plus 3 is 9. 7x minus 4x is 3x, and the 3's cancel. And here we get that x equals 3. And then when I do the y's, I will get that 4y minus 3 must equal 3y plus 1. And then I'll subtract the 3y from both sides. And then I'll add this 3 to both sides. And I get that y equals, these cancel, 4. So x is 3 and y is 4 for number 11. Okay, in number 13, same thing, but now instead of using opposite sides and opposite angles converse, we are going to be using the diagonals converse and the opposite sides parallel and congruent theorem. So in 13, we must have these two be congruent to each other because this diagonal has to have been bisected. Bisect means the pieces will be congruent. So subtract the 4x, I get x. Add the 6 to the 2, I get 8. So x is 8. Yeah, okay. This is getting kind of messy. I'm not a fan of that. How about I gotta do this, and then I gotta do this, and then I could move that over, and then okay. So I'm gonna erase that and write it off to the side. So for number 13, I got that x equaled 8. And that's it. Okay, number 15. Opposite sides have to be parallel, they are, and congruent. So we set 3x plus 5 equal to 5x minus 9. And then subtract the 3x from both sides. I don't know if you guys can hear that or not, but if you can, that's called Scratch Garden, and it is a parent's worst nightmare. It's called Scratch Garden, right, Theo? Oh my God. Okay, 14. So now we divide both sides by 2. Oh, she's coming closer. You're going to hear Scratch Garden. Divide the 2 on both sides, x is 7. Okay, let's keep going. Oh boy, fun. Number 17 wants us to show that this quadrilateral with these given vertices is a parallelogram. So here's what I'm going to do. I don't think I need a really great accurate graph. So what I will do is okay. Man, that's so distracting. Okay, so what I'm going to do is I'm just going to draw a parallelogram. And it's A, 0, 1, B, 4, 4, C, 12, 4, and D, 8, 1. Now, if you want to draw this accurately on a coordinate plane and plot everything, no problem whatsoever. You can absolutely do that. Here's the thing. By definition, we have a lot of options on how to prove that this quadrilateral is a parallelogram. We have 5, to be exact, 5 options. Yeah, actually. Maybe if we had graphed it, it would have been nice. Because notice how this is at 4 and 4. That means that the difference, the distance here is just 8. And then over here, 1 and 1 means the distance here is just 8. So opposite sides are congruent. Only this one, not those. Okay, you know what, guys? I'm going to do an accurate graph so that I can be kind of more helpful. Sienna, if you're going to listen to music, love, can you do it upstairs until I'm done with this homework? Can you listen to music upstairs?
Okay.
Because I'm doing something, baby. I'm recording a video. Yeah. When I'm done, I'll let you know, and then you can bring the music down. Is that okay?
Yeah, but what am I going to do upstairs?
Baby, I need you to just do something upstairs until I'm done, okay? Okay. Okay, here we go. I feel like I should just start this video over. There's been way too many interruptions. Okay, all right, here we go. Let's do it now. I just needed these grid marks to get a little smaller so I could actually graph something. I actually need them even smaller to get 8 on there. So I'm figuring this stuff out, kind of. It's all new for me. I'm not very good at technology, as you may have heard me say in class. Okay, let's do it now. So what just happened? Wait, what is going on? I don't understand. Oh my gosh, I have done something really weird here. Okay, I don't know what I did. Oh, what the? You guys. What is happening? Oh my gosh. You know what? Forget this. I don't need this. I have paper. I'm gonna do 17 and 19 for you guys on normal paper, because normal papers never treated me that way. Okay. Oh my god, this won't even let me zoom in anymore so I can see. Okay, so number 17 is okay, sorry guys. Here we go. A 01, B 44, C 12.4, and D 8.1. Okay, here we go. So A is 01. B is 4, 1, 2, 3, 4, 1, 2, 3, 4. C is 12. Wow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4. And finally, D is 8. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 1. Okay, here's why I changed my mind about doing the real graph. Is because I noticed that between two sets of points, one of the coordinates was the same. The y coordinates were the same. And then between the other two as well. So that told me that they are horizontal, which meant that I didn't have to do distance formula to see how long they are, which meant that being able to count how long they are was important. It was just going to save me time. Because if you remember, we have 5 ways to prove a quadrilateral is a parallelogram. And I'm going to choose the way that's the least amount of work for me. So looking here and noticing immediately that this is 1, 2, 3, 4, 5, 6, 7, 8 long. And this is 1, 2, 3, 4, 5, 6, 7, 8 long. I have proven one set of opposite sides congruent already. So now, I only need one more thing. I have an option. I can do distance formula here and distance formula here to prove that these guys are congruent, and then I will have proven this by the converse of the opposite sides congruent theorem. But what I'm going to do, because it's easier, is go with the theorem that says opposite sides, one set of opposite sides, both congruent and parallel. That's the easiest way on this one. We've already shown it congruent, and they're both horizontal lines with a slope of 0. So I know that they're parallel. And to prove that the slopes are 0, I can do the slope formula, which is y2 minus y1 over x2 minus x1. And that will be between BC. It will be 4 minus 4 over 12 minus 4, which is 0 over 8, which is 0. And then between A and D, it will be 8, it'll be 1 minus 1 over 8 minus 0, which is 0 over 8, which is 0. So boom, by the opposite sides parallel and congruent theorem, this is a parallelogram. Okay, number 19. 19 tells me that J is -2, 3, K is -5, 7, L is 3, 6, and M is 6, 2. So let's go see what we get here. So I guess it's useful to graph it. You'll see what's the easiest way. -2, 1, 2, 3. This is J. And then -1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. This is K, -5, 7. And then 1, 2, 3, 1, 2, 3, 4, 5, 6. This is L, 3, 6. And then we have M, which is 1, 2, 3, 4, 5, 6, 1, 2. Okay. And connecting these guys up, so I can see that I'm not going to get as lucky as before where I can just count and see how long something is. So I don't know about you guys, but I'm not a huge fan of that distance formula. So if I don't have to use it, I typically won't, okay? Yes, I can do distance formula once twice, 3 times, 4 times to prove that opposite sides are congruent and be done here. Or what I'm going to do is use the definition of parallelogram. And the definition of parallelogram says opposite sides are parallel. Which means if I can show the slopes of opposite sides are the same, I have shown that opposite sides are parallel. So let's look. From this point to this point, we go down 1. So that is -1. And then to the right, 1, 2, 3, 4, 5, 6, 7, 8. Right 8. That's +8. So this is the slope of KL. Okay, so last time I used the slope formula to do it. You're more than welcome to still use the slope formula, okay? But I just want to show you different ways and frankly lazier ways. So here we are. Then I'll go to J and I'll do the same thing. What's the slope of this? So slope of JM. I go down 1, so that's a -1 over 1, 2, 3, 4, 5, 6, 7, 8 over 8. So the slope of that is -1/8. So these guys are parallel, in fact. Okay, now we're going to do the same between KJ and LM. So from K, I go down 1, 2, 3, 4. Down 4 means -4. Over 1, 2, 3. To the right 3 means +3. And over here, slope of LM will be down 1, 2, 3, 4 over 1, 2, 3. So -4, +3, and boom, these slopes are the same, which means that this line is parallel to this one. So we have proven that that is a parallelogram by the definition of a parallelogram. Okay. I don't know if I dare go back to the iPad after what happened, but let's try. Error analysis, it says, what's wrong here? DEFG is a parallelogram by the parallelogram opposite sides converse. I'm looking here. I do see that we have 2 sets of sides that are congruent. But the big question is, are they opposite sides or are they consecutive sides? Because opposite sides need to literally be not touching each other. But this 7 and this 7, they do meet. 7 is actually opposite that side. And this 7 is actually opposite that side. And we do not have opposite sides matching, okay? In this problem, we unfortunately have, these are consecutive sides. So this is not a parallelogram. We'll learn later, but what this actually is a kite. Kites are cool. Okay. 23. Okay, I really like this one. I brought this up in class with you guys. It's cool because we have so many different options using different theorems, okay? So you could use any of those options that we had. Like you can show with these if opposite sides are congruent to make it a parallelogram. So we can say that 5x must equal 3x plus 10. And then we'll solve for x. 2x equals 10, x equals 5. So that's the value of x that would make it that. And then I used opposite sides to do it. And I can plug this 5 in here to make sure this is 3 times 5 is 15 plus 1 is 16. And here 5 times 4 is 20 minus 4 is 16. Opposite sides congruent. We've got a parallelogram. I also could have chosen instead to do diagonals bisect each other and say that these two must be congruent and these two must be congruent. And I could have done it that way, and that should have still given me the same exact stuff. 2x plus 1 equals x plus 6. Subtract the x, subtract that, I get x equals 5. And then again, plug it in here, I get 20 minus 2 is 18. And over here, I get 15 plus 3 is 18. Oh, look at that. The diagonals are bisected. Therefore, it's a parallelogram. Either way, whichever way you did it, x is 5. Okay, and that was it. Sorry for the interruptions. This one would have been quicker otherwise. But, alrighty. Have a good weekend, you guys. Bye.